Hello everybody, I'll be solving a quick uh, physics problem today on linear momentum. Now before I begin, I just want to point out that this is my first time using this technology, so if I'm a bit choppy, so please let me know and I'll use your suggestions to improve my future videos. Alright, so I've learned that the most efficient tutorials are the ones that are short and to the point. So I'll give you a quick second to read the problem, and I'll get started right away. Now we know certain things about this problem. Well, we know the mass of car 1, which is 1100 kilograms. We know the mass of car 2, which is 1300 kilograms. We know the coefficient of kinetic friction between the wreckage and the road. That is 0.8. We know the mass of the wreckage, which is just m1 plus m2, is 2400 kilograms. We know the distance that the wreckage traveled. That is 18.7 meters. Alright, so let's visualize this problem. So this is car 1 traveling east, car 2 traveling north. They collide, and that collision is an inelastic collision or sticky collision, and it travels 18.7 meters. We know the final velocity, which is 0, because obviously it slows down and stops, and we know the initial velocity, which is, well, actually we don't know the initial velocity, but that's what we're trying to determine. But we do know that the force that causes this wreckage to slow down and stop is the force of friction. So we're now going to solve for the force of friction. Well, we know that the force of friction is equal to mu times the normal force. Well, the normal force is mass times the acceleration due to gravity. So let's just write that down here. So if I was to put this over here, if I was to substitute mu for 0.8, mass for the mass of the wreckage, and so sorry, that's 2400. Looks like a 1 almost. And if I was to substitute negative 9.8, I would get negative 18,800. So I'll write that again. 816 newtons. Now I've done the calculation beforehand just to save a little bit of time, so that's where these numbers are coming from. So now that we know the force of friction that caused the wreckage to slow down to a stop, we can determine the initial velocity. So to do that, we're going to use this formula right here. It is one of the big 5 motion equations. So it is Vf squared, so the final velocity squared minus the initial velocity squared is equal to 2a delta d. Now, well, we know, although we haven't determined the acceleration of the, or I should rather say the deceleration of the wreckage yet, we can easily determine that. Well, we know the force of friction, and we know the mass of the wreckage, and by Newton's law we know that force equals mass times acceleration. So we put in the force of friction right here, put it in here, so we substitute force of friction for negative 18,860 newtons, we substitute the mass of the wreckage for 2,400 kilos, and we will find the deceleration, which is negative 7.84 meters per second squared. Now we're going to take the acceleration and substitute it for a here. So I'll just do that on the next page. Okay, so Vf squared minus Vi squared equals 2a delta d. Vf squared is 0. Vi squared is what we're trying to find. 2 times a, which is negative 7.84. and delta D is 18.7 meters. Actually, let's do that. So the initial velocity, and I've calculated it on my calculator here. That turns out to be 17.1236 meters per second. Okay, so now that we know the initial velocity of the wreckage, we can use that in conjunction with the conservation of momentum to determine the two velocities of the car. We know that because this is an inelastic collision or sticky collision, this equation stands to be true. So so the momentum of the first car plus the momentum of the second car is equal to the momentum of the wreckage, right? Because momentum is always conserved. So I'll just do that. Okay. And yeah, so that's m1 plus m2 equals v prime. Now this folks, we found to be, so this v primed is really just the initial velocity of the wreckage. So we know what this is. All right, we know what this is. We know the mass of the wreckage. We know the mass of car 1 and the mass of car 2. So how are we going to determine the two velocities? Well, if we go back to the first quick diagram that I sketched, you'll notice something funny actually. If you really look at it, and actually I'll just draw it again here. I'll do it on a new page. So as you remember, folks, this was car 1, this was car 2, they both collided, and this was the wreckage. However, and we're told, yeah, that's all we're told. But if you look at it carefully, this really just is the vector components of this vector. So if we were to we're to draw that again, we can do this. We can do that. Now, this vector corresponds to this vector right here, and this corresponds to that. It's just I'm sketching it in a way that makes really obvious that the wreckage is really just the result of these two vectors. Alright, so we first want to determine the momentum of the wreckage, and we'll let that momentum be this vector. The vector of the wreckage will be the momentum of the wreckage. So this vector is the momentum of the wreckage. And it'll make sense very soon. It'll make sense very soon why I am letting the vector be a momentum rather than velocity. Okay, so now that equals mass 1 plus mass 2 times the velocity, v prime, and I've done the calculation, and that is 41,096. 0.64. That's okay. I'll just write the units right there, meters per second. Okay. So now we know that this right here, this vector, the momentum vector of the wreckage, is this. So we can use this information. We can use this information to determine the two vector components. Well, we know first of all that it travels. The wreckage travels at 30 degrees. Travels at 30 degrees northeast. That's stated in the question. So, using some knowledge of trigonometry, we can determine. So I'll just write this. I'll just write it right here. That's the momentum of car 1 and the momentum of car 2. So the momentum of car 1 is equal to the momentum of the wreckage sine 30 degrees. So similarly, the momentum of car 2 would be the momentum of the wreckage cos 30 degrees. So all I'm saying is that the momentum of car 1 is the vertical component of the wreckage vector, and the momentum of car 2 is the horizontal component of the momentum vector. So if you were to solve this, we would get 590.7 kilograms times mass divided by meters times meters per second. And similarly, the momentum of the second car would be 20,548.32. Now, given this information, so folks, now we know that this really should, I'll redraw that. Okay, yeah, that's not helping. Alright, so we know that this number is equal to mass of the first car times the velocity of the first car. And you might just be able to now see why I let the vectors be momentum vectors instead of velocity vectors. Now that we know the momentum and we know the mass of the two cars, so I'll just quickly write that here, mass 2 times, right there. So now that we know the momentum of the two cars and we know the masses of the two cars, we can determine the velocity. We can determine that and that. So the velocity of the first car is 35,590.7 divided by 1100, which turns out to be 32.355 meters per second. Actually, you know what, guys? I think I'll do it on a new page because it's getting kind of crowded. So I'll just go to a new page, and so the velocity of the first car is the momentum of car 1 divided by the mass of car 1, which is 32.5 I'll just do 36 meters per second. And the velocity of the second car is the momentum of the second car divided by the mass of the second car, which is 15.806 meters per second. Now, the question initially asked that if either of these cars was speeding, and the speed limit was 80 kilometers an hour. It was 80 kilometers an hour. So now we're just gonna convert this into kilometers. So the first velocity is 116.478 kilometers per hour, and the second velocity is 56.903 kilometers an hour. Since the first velocity, so since the speed of car 1 is greater than 80 kilometers an hour. Car 1 was speeding. So therefore car 1 was speeding. Folks, I know that this was a long question, but I think it's a really good one because it touches so many of the key concepts of physics, from from vectors to momentum and kinematics, um, and it's great because it wants you to use your knowledge of physics to infer, um, infer information from a problem. So we inferred that car 1 was speeding. So I hope this video helped, and sorry for dragging it so long. It's just this was a a multifaceted problem, so we really had to work it out. So once again, guys, just let me know how I can improve to make my videos better, and thank you for watching.